Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about submarine. Why? Well, it was requested in our live stream. So first we have to understand the aspect of buoyancy. Now buoyancy is basically in simplest term upward force exerted by the liquid. Now liquid could be anything. It does not have to be water. It could be alcohol. It could be ethanol. It could be whatever else you think about. It just has to be a fluid. Now there is one core requirement. It must be in non-linear reference frame, meaning it cannot work in ISS. It has to be in a place whether you have gravity or you have acceleration. Otherwise it will not work the same way. That's why like fires are very dangerous in ISS, because again like hot air rises like a fluid. That does not happen in zero G environment. So this is one thing you must understand. Buoyancy only works if you have gravity, basically non-inertial reference frame. Now what does it mean? That simply means displacement is the key. If you understand, basically if you put an object somewhere in a fluid, it must displace a certain amount of fluid. Okay, let's say it displaces X amount of fluid. Now X amount of fluid must have a certain amount of weight depending on the density of the fluid, and that's the key. Whether you sink or swim or you get stuck, that is directly proportional to the weight of the amount of liquid you displaced. So if your weight is basically higher, the liquid that is you displaced is higher, you will be pushed upwards. If the weight of the liquid is not sufficient enough, you will sink. If the weight is exactly the same, you will get stuck. Basically stuck as in like you will float. So that's the whole point. The amount of water you are displacing, all you have to do is to calculate its weight. So how the heck you think like big giant container ship stay afloat even though it's literally made out of metal? Well, just think of it its way. Displacement, basically if they are displacing let's say X amount of water, the weight of that water column that they are displacing must be higher than the ship maximum weight, otherwise ship will sink. So that's all you have to think of it this way. Now fluids have to be incompressible. That's why it does not work the same way in air, same way as in water. Fluids have to be incompressible, and density matters more than the size. That's why like design have to be accommodating of that. So if you are using, let's say in cases of battleships, the armor was very high density, so they had to design in such a way the displacement is much higher. Otherwise they will end up in a scenario where like displacement may not be high enough. So even minor damage, even minor water leaks will translate into them going under. So this is one thing that you have to understand. The amount of water you're displacing and its weight versus your object's weight, that's all you have to calculate. So how do we achieve control over it in case of a submarine? Now one thing you must understand, all we have to do is basically have air and water in a fixed tank, meaning if you have a tank, you can flush it with either air or flush it with water. And generally it will not be wise to call it air tank or water tank. That's why we call it ballast tanks. Now ballast tanks, if you have control over them, basically how much air it has or how much water it has, it will allow you to control, basically raise or lower your vessel. Now this is one thing that is present in almost all seafaring equipments, including container ships. This is one thing that you may think about, oh, only submarines. Nah, trust me, everything uses that. Anything that has like something that can shift generally requires to have this for stability. Anytime you have a scenario where you may have to go under the bridge, how would you go there? Like for example, let's say a container ship fully loaded is low enough that it clears a bridge. Awesome. But what if it dumps all its equipment, basically like unloads everything? Then what the hell? Then you have to utilize ballast tank to sink it properly. Sink as not as in like sink underwater, as in the water level will rise and control. If you have a crane, many times if you are deploying the crane, basically you are moving objects, you may want to go a bit lower to anchor yourself a bit better. Anchor as in from a gravity point of view, not physical anchors. So ships and submarine, all of them have it, and it's a very extensive. This is like what captain knows how to deal with, because in case of submarine it's ludicrously complex, because there are main tank that controls your X and Y height, basically how deep or shallow you go, and then there are tanks on front and back that controls the trim. And be mindful of that trim changes, because let's say you fire torpedoes are not few gram equipments, they are multi-ton equipment. So if you changed multi-ton literally fired from front, now you have to make sure that ballast tanks is compensated for that. Otherwise you may have a submarine that literally if you fire full forward, it comes out of the water. It has happened. So that's why we have ballast tanks in front and backwards. And not to mention fuel consumption. If you are talking about a diesel powered submarine, which majority of the planet is running on that fuel also has to be compensated. So there is a fuel tank which has water tank inbuilt into it. Not water tank as in water transportation built into it, so it can remain more or less buoyant, fixed buoyancy, meaning it should not change. I have provided widget on below, which is a very detailed breakdown of a very old submarine, but the details and principle is exactly the same. So it's far more complex than you think. Like submarines are far more complex. Even basically seafaring vessels are, they are complex, but again, that's what captains are trained for. It's like, how do you raise the ship? How do you make it stable? How do you make it efficient? Everything has to be calculated based on your ballast tank. Ballast tank is your control vector. So how do you power a submarine? Thankfully, it's only two things that can truly do it. One is nuclear, another is battery. Now, there had been some experimental system which tried to use hydrogen and liquid oxygen. It did not work out that well, because be mindful, this is a war kind equipment. So it has to design to take a beating, like serious amount of punch to its face and still survive. Hydrogen and oxygen in a confined space, yeah, no. That's just a nope system. The most advanced thing I have heard, because be mindful, at this point in time, if you look at any US submarine that is not nuclear powered, even nuclear powered one will have battery backups. They are generally lead acid battery. Like, why the hell nobody is using lithium ion? Well, there is one Japanese submarine that's supposed to be using lithium ion, and I'm reasonably sure they must be using lithium titanate batteries, because again, I do not like the idea of putting, like, flammable things in an enclosed space. So it does make sense to use lithium titanate. It does have like longer lifespan, and these equipments are idiotically expensive. So enduring the lifespan is something that I think they will use, and it's low quantity enough that they should be able to afford it. So nuclear and battery, that's the only option. And how the heck you charge that, like, battery? You use diesel generator like anything else when you have to surface. Now that limits your endurance, meaning how long can you remain underwater directly depends on your battery bank. If your battery bank is big, healthy, reliable, it will stay underwater for days. If it's not healthy, not reliable, which has happened with Indian submarines, it could cause catastrophe. So it's one of those things that battery is the limiting factor, not the diesel generator, the battery. Because be mindful, diesel generator will work as long as you have fuel, but it requires you to be above, or at least have a snorkel up there that is sucking up air and dumping out basically gases, which is doable, but it does make you vulnerable. And if spotters are there, like enemy spotters, they can spot it. Hey, torpedo, boom. So to be perfectly stealth, you have to go on batteries, and these batteries are lead acid batteries, are huge, meaning they don't have like 100 amps, they have like 4,000 amps per cell. So they are ludicrously huge, and they do have very long lifespan. Like many times lead acid people, they do not last. Again, by this sort of cells, they last for 25 years. So you can use batteries. Now you may be like, why don't we use nuclear for everything? It is perfect, it does work for a very long time, as in 10 years before it requiring anything else. So problem is, it's very loud. Now, like, why the heck a nuclear reactor is loud? Well, even if you can turn off the power plant system, you still have to run coolant pump that is running coolant through the reactors. So if you are in a busy port, that's not an issue. Like if you are like, spying on somewhere that is busy, let's say a dock, not an issue. But if you're in the middle of nowhere, calm, the other person is like, bro, I can see you. That's the problem. Like, bro, I can see you. And that's what has happened. NATO generally does a lot of military exercises, and one of the basically Sweden submarine can literally penetrate them. It's like, how the heck that happened? Because it was using Stirling engine, which is even quieter than diesel engine, and nuclear submarine could not detect it. It's like they went like mock torpedo, and it's like, yeah, we sunk your aircraft carrier, simply because it was quieter. So be mindful, nuclear does work, but does have a consequence. If you are in a busy environment, that's good, but in a quiet environment, it backfires on you. It's like, bro, the coolant has to work 24/7 on that. So that is a limiting factor. That's why not every country is like, let's make as many nuclear power as possible. Some nuclear power, good. Every single submarine is a nuclear power. That means you are vulnerable to one thing. So that's one issue. And how do you provide other things? Basically, fuel for the person. You electrolyze the water to get oxygen. That is our primary fuel source. And for water sake, you desalinate the water. Generally, nowadays, we have RO plants on submarines to provide power and air continuously for as long as they have to, or as long as they have fuel. In case of nuclear, it's indefinitely, basically for 10 years. In case of diesel, generally few months. So that's the power side of things. What about crew? Now, this is the main aspect of any army, because you may think, oh, submarines are idiotically expensive, like multi-billion-dollar things. Here's the deal. It's cheap compared to the crew of it, because crew is the main limitation. Like if, for example, India has a huge army division, like armed forces, you take that many people and you try to sort them out, like how many people can actually survive a submarine duty, it will be like go from this to this. Like these people are best of the best of the best, because it is brutal environment, meaning submarine work is brutal. Most things are automated nowadays, and modern ships are almost automated to a point where only few crewmen can do it. But you have to train your crew in such a way that in case of a breakdown, in case of a failure, in case of a fire, because it is a battleship underwater, things going bad is like something you train for, something you were supposed for. They are like built like a tank. So basically, they have to be strong, capable, and sharp underwater without seeing sunlight and inside a metal tube for a very long time. So you can understand that is very brutal environment. And to understand the importance of that, food budget for every submarine crew is very high. Meaning, Americans generally joke about it. Like if you want good food in army, you go to submarine. Like that's how good their food chefs are. Like they have to, because this is one thing they have learned. Army morale matters, and Russia-Ukraine war have proven that army morale matters a lot. So US have learned the hard way that they must make sure that food quality is highest as possible. And that is the biggest limitation. Even in a diesel system, even with like if you have good battery system, let's say for Japanese system, and everything is efficient enough, you can have a scenario where you can last more than, let's say, 70 days or 80 days. Here's your food supply will not last. So that is one issue. That means you have to come to surface. You have to come to a place where you can resupply, because emergency ration will not last very long. So that is a final limitation, not the submarine itself. Even in a diesel submarine, it's the food endurance. And not to mention the people that you have trying to find for them has to be tip-top quality in terms of psychology. That is very rare. That's why it's fair. You can find people who are like built like a tank, who are strong, capable in open environments. They're like, I got this, fam. The moment you put them inside a metal tube like this, they're like, no. So this is one thing you have to understand. They are like not for everyone, and best of the best only. So that's why whenever crew loss happens, it's a very serious loss for a country. Country can replace submarine like not an issue. Crew, yeah, good luck. So this is one thing that is seriously limiting every country's navy. Where it's like, we can't have like 100 submarines. Because even if you try to build 100 submarines, assuming you can afford it, how the heck you will man them? And man them safely. Not as in like just man them. Safely. Like crew rotation in US systems are like around 77 days. And what about communicating with it? It's a battles equipment. You have to communicate. Here's the problem. You cannot. Because water is opaque to almost all electromagnetic spectrum. Meaning it's so opaque that you can surround a nuclear reactor with water and gamma rays will not penetrate it. That's how opaque this puppy is. And it can absorb insane amount of energy before it boils. So fundamentally speaking, you're not going to try to boil off the sea. So what can you do? You have to go low, as in really, really low frequency. Now, how low we are talking about? The technical term is extremely low frequency. Now, to give you a context, how low we are talking about is about 3 hertz to 30 hertz, not kilohertz, not megahertz, definitely not gigahertz, 3 hertz. That's how low it has to be. Now, there is another problem with that. It's only one way. Now, like, okay, we can communicate. Then why the heck it's one way? Because the antenna to have that low frequency is measured in kilometers. Let that sink in. The antenna could be like, if it's suspended in air, it could be hundreds of meters. And if it's buried underground, it could be 10, 20, or even 50 kilometers long. That's the antenna size. So that's why it's only one way. Only few countries have built it. India has it, USA has it, China has it. And I'm reasonably sure US have shut down theirs. So it's like, yeah, it does not serve any function because the bit rate is very low bit rate. So a submarine have to come to the surface in order to, confirm, or especially if you are talking about nuclear Trident missiles, you have to confirm, double check. You can't just like, I feel like I should launch a nuclear missile, or like, I'm receiving a signal on my like ludicrously low where we cannot have advanced encryption or any back and forth. So you have to come to surface. So that's why it's not that desirable. You can have it. It's a good thing to have, but not really that practical from a military point of view. So communication is flat out impossible. You have to come to surface, and the moment you come to surface, even to the snorkel depth, basically where you can have that small buoy generally is attached that allows for communication, yeah, you can be spotted. At that point in time, your stealth is gone. So the communication is also limited. And these are the two things that why submarine is not, end all be all of everything, because they can be, if you can have a crew that can man it for, let's say, 10 years in case of system. And if you have a communication system that works underwater without being detected, it will make it a perfect system. But thankfully, those two things keep it limited. You really don't want a tool that actually gives a country an idea. It's like, you know what, we can fight a war and we can win. You don't want that. You always want even a best country to be like, you know what, do we really want to spend that much blood on it? So communication and crew, they are the two limiting factor of any and all submarine. Everything else, we kind of got it down. So this was my presentation on the submarine. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.